Good morning to everyone. Myself, Professor B. Ashok from School of Mechanical Engineering, belongs to the Department of Automotive Engineering. Today we are going to see the about Introduction to Engine Electronics. This PPT belongs to the, or you can say this session can be useful for the B.Tech and M.Tech students who are pursuing automotive engineering. In that, the course belongs to the Automotive Electronics. Especially the syllabus is based on our internal purpose for our V8 University Vellore. Let's enter into the presentation. As you might be aware of that modern engines nowadays, it is vary from a single cylinder to 16 cylinder up to 32 cylinders engines also has been used in higher category vehicles, or you can say higher performance and higher speed oriented vehicles. Like here in this slide you might be able to see there are different varieties of engine varying from a small size to the bigger size. Like this is a typical 3-cylinder engine, and this is a typical higher size engine, and all these engines all nowadays are controlled by means of an electronic means. Previously, if you will take before 10-15 years, possibly in India, there is no engine is controlled by means of electronics. But nowadays, without electronics, you can't able to even start the engine. You can't able to move the vehicle. This is the scenario behind the engines which has been using electronics by different OEMs. So why this scenario has been happened, or what is the need for using this kind of electronics in an engines? There are different technologies plays a major role in the using the electronics in an engine control. Possibly the different technologies has been utilized or used. This technologies has been demanded by the different varieties of persons. Primarily the major reason behind the electronics has been put into the engine nowadays is the legislation, that is the emission norms. For example, in India we are, as of now in 2016, we are following BS4 norms, that is Bharat Stage 4 norms, which is set by the Automotive Research Association of India, or ARI, along with SIAM, Society of Indian Automotive Manufacturers. Likewise, in the other countries, European countries, other countries, they are following the other emission norms. For example, in European countries at all, as of now today, they are following Euro 6 norms. But in India, we are lagging with the BS4 norms. Euro 4 norms is equal to BS4 norms, equivalent to. But we are still following the BS4 norms. So what is this emission norms means? Depending upon the emission norms, there is a certification will be provided by the certifying authority like ARI to the respective vehicles. So like emission has to be this much level. Like there are different varieties of emission has been emitted from the vehicle, like CO, HC, NOx, all those things. This has to be in this much level. So in order to reduce these emissions and improve the performance by the OEMs, for example, OEMs demand is nothing but they want to be producing the competitive vehicle in the market. Like my vehicle is giving a 25 km per liter. My vehicle is giving 20 km per liter, 23 km per liter. So this is a competition, and the customers' expectations. Like customers, as a customer, we are expecting many things from the vehicles nowadays. Engine has to respond quickly, and engine has to be running very smoothly, no noise, and very quick pickup, like this. And similarly supplier requirements, supplier like those who are supplying the components to the OEM. So this all these requirements make the new technologies has been put into the vehicle, especially nowadays in the engine. So like these technologies has been put in a different classifications. Like almost nowadays the electronic control has been used in all the parts of vehicles, starting from the drivetrain. Drivetrain is nothing but a combination of engine plus a transmission system, and chassis related electronics, and similarly interior related electronics like telematics, application, passive safety, active safety, all those things, and similarly body related like pedestrian protections, smart body systems like that. So this makes an electronic systems to be inbuilt or used in it have to be used in modern day electronics in all category of systems in the vehicle. if you will see the automotive software, up to 40% of vehicle cost as determined by the electronics and software as of now today. So if you will take the whole cost of the vehicle up to that, in that 40% of the vehicle cost will be determined the software. And one more important thing is the 90% of all new innovations, or you can say 90% of new technologies has been produced, or you can say set with the help of electronic systems only. And one more thing, we are saying that 50 to 70% of the development cost will belongs to an ECU. ECU is nothing but the electronic control unit. And for example, engine is controlled by an ECU. Similarly, braking is controlled by an ECU. Airbag is controlled by an ECU. So like that, there are plenty of systems has to be controlled by an ECU. A premium car may have up to 70 ECUs in a vehicle. If you will take a normal Indian hatchback vehicle like a Maruti Swift or Maruti Swift Desire, it might be itself having a 10 to 15 or minimum 15 ECUs. If you go for a premium vehicle like Mercedes, BMW 7 Series, Mercedes S-Class, in that category, the number of ECUs count will be even higher. Here the study shows that there will be a presence of 70 ECUs in a vehicle. So, and I will give you a slight introduction about the engine electronics. Automotive electronics first began with the need of better controls for the engine. So if you will see the normal mechanical carburetor system in case of SI engine, or if you will say in case of a mechanical fuel injection system in case of a CA engine, it might not be able to provide the real-time operating conditions, and it might not able to give a better output as expected like a electronic control. So the automotive electronics very first is introduced in the engine control. In fact, first part in automobile were used to control the various engine functions and were referred to as ECU. At the very first electronic component, apart from the lightning system, all those things, the ECU, earlier it is called as a engine control unit, because as it is introduced only in the very first in the engine, so it is called as a engine control unit. But later on it has been used, same kind of control unit has been used in other system controls. So nowadays it is called as a electronic control unit. If the electronic control unit used for the engines, then it is called as a EMS, or you can say the engine management system, or ECM, engine control module, or in some categories they will be calling it as a PCM, powertrain control module. So this these all terminologies determines the, or you can say defines the same thing, EMS, ECM, or a PCM. It is nothing but a electronic control unit belongs to the engine. Until late 1960s, control of engine output, torque and RPM was accomplished through some combination of mechanical, pneumatic and hydraulic systems. That is either with the help of a carburetor system, there they will use a mechanical, pneumatic or hydraulic system, same in case of a CA engine. So the engine output will be controlled purely with the help of mechanical, pneumatic and hydraulic systems. Then in 1970s, electronic control system were introduced because of the emission legislation and the technology demand and the to improve the performance category, or you can say the performance of a vehicle. One of the most demanding electronic parts of an automobile is the engine control unit. Engine control demand is one of the highest real-time deadline, as the engine itself is a very fast and complex part of the automobile. Of all the electronics in any car, computing power of an engine control unit is the highest. Typically 32-bit processor will be used. So typically an ECU is nothing but it consists of a microprocessor or a microcontroller. It consists of a internal memory, and based on the program, the input and output informations will be given to the, or you can say the input informations from the sensor. Sensors will be sensing the real-time operating conditions of the engine, like pressure, temperature, speed, airflow quantity, like etc. So it will measure all those informations, and based on the program written, and it will control the output actuators like throttle valve, injector, spark plug, etc. So for this, a typical modern day engine electronic control unit uses a 32-bit microprocessor. What motivates to a engine electronics? The motivation for electronic engine control came as a regulate automobile exhaust emission and improve the fuel economy. Nowadays it is used for other purpose also. Yes, as I have already told, the important requirement for using the electronics in the engine is the one is the exhaust emission control and improve the fuel economy. Legislators all over the world are specifying increasing the tougher emission limits for diesel engine and as well as the petrol engines. To comply with the requirements, emissions from the drive system are constantly being reduced. So the toughest emission norms can be able to control with a closed loop control. Like closed loop control in the sense, for example, if you are using a typical mechanical system along with a combination of pneumatic systems, you can't able to control the emission norms in a closed loop. So whatever you are providing the input, the output will be the combustion will be happening and output will be producing. You can't able to sense whether the output produced is with respect to input or not. So in a closed loop system, the output is measured and the output again is fed back through the sensor with the help of sensors, and again it is compared, and then based on that comparison, then again the control functions will vary the airflow quantity or air fuel ratio mixture, and it will try to optimize the combustion and it will try to reduce the emissions. Modern electronically controlled SI and CA engine controls fuel delivery by an electronic control module, or you can say the electronic control unit. So nowadays we will see in India, other than two-wheelers and some of the three-wheelers, all the engines, whether it is a SI engine or a CA engine, it will control only by means of electronic controls. Only the two-wheelers as of now using the carburetor, and three-wheeler petrol engines, they are as of now using the carburetor system. So very soon that is also going to be phased out, and an electronics has to be used in those category type of engines as well. So this is the typical view of an electronic control unit. Like in the picture you might be able to see, this is the electronic control unit belongs to a bigger size engine like a 4-cylinder engine or even more than this, and this is the electronic control unit belongs to the 3-cylinder engine or a 2-cylinder size engine. This is the exploder view. It is nothing but a typical electronic PCB board which has a number of electronic components embedded into it, like microprocessors and as well as the driver circuits, input signal conditioning modules, all those things. And this is one of the first or you can say critical part which has to be manufactured, or you can say which has to be developed in modern day engine category, or you can say engine development thing. No OEM will develop the electronic control unit. For your information, no OEM, original equipment manufacturers, for example Maruti, Volkswagen, Bajaj, any OEMs, they will not develop the electronic ECU for any category of control. Only the ECUs, especially the engine ECU, will be supplied with the by the suppliers, tier 1 suppliers like Bosch, Delphi, Continental. Those persons only they will supplying the electronic ECU, or you can say that with the help of the, or you can say the OEMs will give the demand. I want a ECU for so and so category engine, which it has to give the so and so power, so and so torque, and it has to produce so and so emission, and the cost of the engine should not be more than this. Like that they will give the requirement, and based on this requirement the suppliers, tier 1 suppliers like Bosch, all those persons, they will develop the ECU and they will give back to the OEMs. So the brain of the modern engine is the electronic control unit. It monitors and controls all the key functions of the engines. The control unit also acts as the interface to the vehicle automation system. For example, as I have told you, not only in the engine nowadays the electronics has been used. Other than engines, other systems also using the ECUs like braking system, transmission system, cruise control, all those things. So this engine ECU can be easily communicate, or you can see easily interface with the other ECUs in order to provide the better, or you can say coordinated control. In order to provide the coordinated and efficient control, the engine ECU has to be can be interfaced with the other ECUs as well. So because of this only nowadays this Google driverless car has been introduced. The optimum interplay of the entire drive system is the key to low pollutant emission, low fuel consumption, high power output. Depending upon the software strategy and depending upon the control strategy, you can able to provide the optimum emissions, economy, and as well as the power output. One of the most demanding electronic part of an automobile is the electronic control unit, engine electronic control unit. So if you will see here, this is the schematic representation of an engine electronics present in the SI engine. This is belongs to a single cylinder engine, which is a very simple structure. If you go into the 4-cylinder or a 8-cylinder, the number of electronic components and the software strategy are becoming more and more complex. To be start up with, I just introducing with the single cylinder SI engine. If you will see here in a single cylinder SI engine, the very first are the input sensors. This is the typical electronic control unit, or you can say the engine control unit here, but it could be called as an electronic control unit. And it consists of a typical microcontroller, which has the separate programmable devices, all those things, and driver circuits. This driver circuits and as well as the input signal conditioning circuits. This we will be seeing in the next presentation, like what is an electronic control unit. As of now, you understand that an ECU consists of a input signal conditioning module and as well as the output driver circuit modules. So these are all the inputs, like starting from the throttle position sensor, manifold air pressure sensor, similarly O2, or you can say the lambda sensor or EGO sensor in the exhaust, crankshaft speed sensor, fuel pump control, air temperature sensor. Like this, here they have mentioned accelerator pedal input, accelerator pedal sensor. So here they have mentioned 4 to 5 sensors in a minimum level. But apart from this, there will be a minimum 20 to 25 sensors in the higher category of engines. And similarly the actuators. For example, here you might be able to see the actuators are the output. It's for your information, sensors are input to the sensors are act as the input to the electronic control unit, and the actuators are output from the electronic control unit. So depending upon the sensor value, the real time engine conditions will be monitored. Real time conditions in the sense, for example, what is the temperature right now, what is the pressure right now, what is the inlet pressure, what is the exhaust pressure, what is the exhaust oxygen level, what is the air quantity entering into the chamber, what is the engine speed, what is the cam position. Like this, all the, if you want to add on sensor, you can add, but ultimately the cost will be higher. So depending upon the number of sensors, the number of real-time parameters can be measured in an engine. So that real-time parameters are act as the input to the microcontroller, or you can say the electronic control unit. And based on the input sensors, the program written in the ECU will compare all those things, and it will provide the output to the actuators to provide the okay, right now this is the condition, air quantity has to be this much, fuel quantity has to be this much, spark timing has to be this much, spark duration has to be this much. Like that, output will be given through the help of actuators. Again, there are also different number of actuators, typically from 10 to 15 also actuators will be there, but here as of here they have shown only 2-3 actuators. So the ECM or ECU receives an engine operating parameters from a variety of sensors and controls the amount of fuel, start of injection timing or start of injection, other parameters through the set of actuators to maximize the power and minimize the emission level. These are all the input components, like SI engine ECU input components. If you starting from here, throttle position sensor, air temperature, engine temperature, O2 temperature, ignition switch, battery. So these are all the set of inputs. There are typically 10 to 20 sensors mounted on the engine, which measures the pressure, temperature, engine speed, oxygen level, etc. on a real-time basis. Based on the sensor values, control algorithm in ECU computes the control actuators to be activated for the requirements. There are different actuators like throttle actuator, ideal control valve, fuel pump, fuel injector, spark plug, O2 sensor, lambda heater. So these are all the different outputs. Detailedly we will see about this sensor working or a actuator working in a consecutive lectures. So this is a typical CA engine ECU, or you can say the engine management system. So there will be huge difference. Might be looking like there is a small difference between the hardware point of view, but there will be a comparatively huge difference as compared to the CA engine ECU and SI engine ECU. This is a bit more complicated because this ECU depicting belongs to a 4-cylinder engine. Typically 4-cylinder engine up to the 12-cylinder engine, this ECU can be used. This is the main microcontroller inside the ECU. These are all the signal conditioning ports and power supply ports, and similarly these are all the driver circuits for driving the actuator parts. And these are all the inputs like analog inputs and digital inputs, timed inputs, starting from cylinder pressure, accelerator pedal, air mass value, temperature, rail pressure. So there are lot of sensors will be there, lot of sensors and lot of actuators will be there. So these sensors will be act as an input, and these actuators are output from the EMS. And with both sensors and actuators are mounted on respective places of the engine. For example, accelerator pedal sensor means it will be mounted in the engine passenger compartment near to the driver. And air mass sensor means air mass is the how much amount of air is entering into the engine cylinder. So it will be mounted on the intake manifold. So likewise, each and every component will be mounted on a respective places of the engine. So, and one more thing, ECU operating conditions, because ECU at very first, as it is a sensitive electronic components, because of prior to 1980s, 90s, the development of electronics is not that much in a wide manner. So makes to it creates a difficult to mount the ECU, because if you mount the ECU in a very what do you call in engine compartment, then the longer wire, signal loss, all those things will be happened. But nowadays the ECUs are one of the components which is directly mounted on the engine itself. Directly they are mounting in some vehicles in engine or mostly in engine compartment. So if you are mounting the ECU on the engine compartment or directly over the engine, there are a lot of things needs to be taken care, like see here, salt spray, fuel spray, corrosive liquids, temperature, vibration. So these are all the parameters needs to be considered while developing an ECU. What are the control functions of an EMS? For example, an ECU, or you can say engine ECU, or engine management system. Hereafter I will term as a engine management system. That is nothing but the engine ECU. What it controls, basically based on the inputs and what it based on the input and based on the program written, what it controls. For example, it will vary the air fuel ratio, amount of air quantity, and as well as the fuel quantity. We are saying this, there is a different quantities of air fuel ratio like stoichiometry, lean condition, rich condition. Some at some operating conditions some air fuel ratio will be used, and at some operating conditions some air fuel ratio will be used. So depending upon this, it will control the air fuel ratio, ignition timing, idle speed, variable valve timing, valve controls, cold start control, controlling of EGR, working of AC, because AC is again attached towards the engine. So on and off, switch on and switch off of the AC leads to give the more load on the engine. So at the time more air fuel ratio has to be provided. So that will be controlled. Again, turbocharger, cooling system, onboard diagnostic, control of overspeed limitations. These are all the certain control functions of an EMS system. Like what EMS do in case of diesel engine and in case of gasoline engine. In both the engines, it will control the fuel injection rate, emission control, NOx control, turbocharger control, throttle control, and there is no limitation that only you need to control something. For example, if you will say in case of lower level electronic control, it will control like basic functions like fuel injection, throttle, EGR, turbocharger. But in a higher category vehicles or higher technology level, nowadays the cooling system, lubrication system, radiator, these all the things are again controlled by an EMS system. So engine control system algorithm. How an algorithm inside the engine control system, or you can say the engine management system, how the control algorithm will be designed, or what are the parts of the internal control algorithm part. About this internal control algorithm, I have already given a lecture on the SI engine control system architecture. That for more detailed thing you please go through it, but here I am going to touch upon what are the basic control modules present inside the EMS, like torque control module, electronic throttle control module, air fuel ratio control module, idle speed, ignition, turbocharger. For example, for each and every control function there will be presence of a control module. So ultimately, depending upon the requirement, torque will be finally calculated. This is the torque requirement by the driver. This is a torque requirement by the driver from the engine. For this torque requirement, what is the air mass value, what is the air fuel ratio, what is the spark control. So based on this, each and every module get the information from the torque control module, and it will control the respective other control modules. And one more thing, apart from this, the easy conventional control algorithm in engine control unit are based on a static 3D maps and designed with the help of PI and PID controllers. So 3D maps is nothing but it consists of lookup tables. For example, parameter A is this much, parameter B is this much, parameter C is this much, and control parameter will be this much. So that will be put in the lookup table. So that lookup tables will be taken from the engine testing time, like that is called as a calibration. During the calibration phase, one of the toughest part in the engine ECU development is the calibration, because that requires a huge time and as well as the cost involved, because each and every operating point has to be determined, and according to the operating point the engine has to be calibrated, and that calibrated data set has to be inbuilt in the control algorithm. So by means of this calibrated data, the control algorithm will be operated. So this is again a block diagram of an engine control functions. Like typical controller has the input and output module, which consists of typical input sensors and the output sensors. Like here you might be able to see manifold airflow sensor or mass airflow sensor, throttle position sensor. Fuel metering is nothing but the injector. So this is belongs to the MPFI engine. And heated exhaust gas oxygen sensor, differential pressure sensor, cycle is nothing but a camshaft sensor, position is nothing but the crankshaft speed sensor, coolant temperature sensor, EGR control. So based on these input sensors, this fuel metering, EGO, whatever the other activators, everything will be controlled. So detailedly we will see in the each and every sensor working or the actuator working, we will see in the consecutive lectures. So control modes. So how the for example, I have told you we have discussed as of now about how the sensors are giving the information, and based on the sensor information the program, how the program is written, and based on that program the actuators will be controlling. So for this and different mode the vehicle will be tends to operate. Like in the early morning you are starting the engine will starts to crank, then warm up, then we will call it as a open loop mode, closed loop mode, add acceleration, deceleration, idle. So these are the 7 different operating modes in an engine control, or you can see engine fuel injection controller, and there is no necessity that it has to follow this sequence. For example, here it has mentioned as idling is a last mode, but it is not necessary that idling has to be last. Even sometimes after engine crank also idling mode will come. So based on these 7 different operating modes, the engine fuel injection system will be controlled by the help of the ECU. So what is the control objective? So as we have already told that it will control fuel delivery, spark, turbocharger, etc. So on what objective it will control it? What is its primary objective? Its primary objective is linked to fuel efficiency. It has to provide a better fuel efficiency, lesser emission, and it will improve the vehicle performance. So whatever the control functions are entered, or whatever the control functions are given in the ECU, everything will be related towards these 3 parameters. Need for electronics linked to fuel efficiency, or you can say fuel economy. Fuel economy in an automobile can be improved in many ways, including increasing engine efficiency, reducing aerodynamic drag, rolling the friction and engine loss braking, and to lesser extent by regenerative. These are some other technologies, but the other technologies apart from the ECU control. So there are predominantly 2 reasons for excessive fueling. It leads to increased fuel pressure and extended injector duration. So if you will go with the higher injection pressure, then the better atomization, it leads to better fuel penetration, all those things will happen. And injector duration, more time injection duration also will also leads to produce a more or you can say waste the amount of fuel. So whatever the way, but mainly the fuel efficiency will be linked towards the electronic control. Like there are many technologies or many control functions based on that you can improve the fuel economy. For example, cylinder deactivation. The cylinder deactivation is nothing but if you are coasting down the hill, if it is a 4-cylinder engine, then you can deactivate 2 cylinders injection. That is done by means of ECU knows. So by based on that you can improve the 8% in the fuel economy. Variable valve timing. depending upon the input and output timing of valves opening, you can able to vary. But in case of a mechanical injection, you can't able mechanical engines, you can't able to do this. By that you can improve the fuel economy by 5%, and because of the electronic injection you can improve the by 12%. Since in case of mechanical injection you can't able to increase the injection pressure, and the fuel atomization will not be proper, combustion will not be proper. But in case of electronic injection you can improve it by 12%. And integrated starter alternator, like integrated starter alternator is nothing but integrating the starter and alternator both in a single component, because starter will be working in a beginning only, and the alternator will be working rest of the time of the engine is operated. So there you can improve by 8%, and turbocharging and supercharging you can improve by 7.5%. So these are all the technologies related to the these are the technologies related to fuel economy in the fuel economy improvements. And next to the link to the emissions. So like if you will see integrating normally the complete combustion may able to produce only the CO2, water vapor and energy. But however, in reality, there are a lot of emissions will be produced like HC, CO, NOx, all those things. Nowadays, because of the electronic controls, you can optimize the airfield rate, optimize the valve timing, EGR, coolant rate, etc. So based on this, you can able to reduce the emission. And of course, nowadays we are using the different after treatment devices like catalytic converter, urea dosage, that is SCR, DPF, diesel particulate filter. These EGR, these are all certain technologies you can able to reduce the emission level, and these are again controlled by means of with the help of the engine management system. And apart from the regular control or a normal control functions like injection, emission, vehicle performance, nowadays some of the electronic components, or you can say the new systems are introduced in the engine, like the engines has been like what I mean to say, the new systems will be introduced by replacing the normal mechanical systems that we are going to see. These three are the important technologies. One is the electronic controlled coolant pump, similarly lubrication pump, fan, electronically controlled fan, that is the radiator fan or intercooler fan, and e-booster, or you can say the turbocharger. As of now we are using the mechanically operated turbocharger with the help of the exhaust gas, but there is a help lot of research is going to use a e-booster or a e-turbocharger, electronically driven water pump. Like if you see nowadays the present vehicle are using the mechanical water pump only, which is normally coupled towards the engine crank belt. So sometimes depending upon the engine output only the pump will be operated. Sometimes the coolant flow need may be higher, and sometimes the coolant flow may need be lower. So but if it is coupled to the crank belt, it can't able to be real timely controlled. But electronically controlled water pump, like the water pump will be controlled by a separate electronic motor, and that pump is controlled by the EMS. Based on that you can able to vary the pump coolant flow, all those things. So in percentage it is used in the higher category vehicles like BMW 5 series. And similar case for the oil pump as well. The oil pump is nothing but a lubricating oil. The lubricating oil also again controlled by means of the oil pump nowadays. And fan control, that is a cooling fan. If you will see the radiator fan, sometimes it may need a better cooling, sometimes it may not need a cooling. So depending upon the engine temperature, the cooling fan speed has to be varied. But the present engines are using the fans which is attached towards the crankshaft. So it may not able to real time optimized. So for that again it is using the electric fans. That electric fans is controlled with the help of motors through the engine management system. And similarly the exhaust turbocharger, instead of using, nowadays we are using the exhaust turbocharger. With the turbocharger is driven by means of the, what would you say, the exhaust gas. The waste energy from the exhaust gas is recovered with the help of a turbine attached in the exhaust part, and that turbine in turn will rotate the compressor which is attached, and it will compress the intake air. Instead of that, the nowadays research is going to replace the turbine with the help of an electric motor. And similarly EGR valves. These are some of the advanced technologies which is used nowadays. and variable valve timing. This is one of the important technology you might be able to see in case of Toyota vehicles and Honda vehicles. Predominantly they are displaying, we are using these technologies, and almost other vehicles also using, like VVT, VVTA, VVTech, all those are similar, and minor difference, like VVTA, VVTech. In all these technologies, valve timing and valve lift will be controlled. Valve timing in the sense the timing at which the valve has to open, and the lift duration, all those things will be controlled. And if you will see in case of BMW vehicle, they are using the Valvetronics. Valvetronics is nothing but they have removed the throttle valve itself, and I hope you might be aware, throttle valve will be present before the intake valve, and it will vary the airflow quantity. And they have removed the throttle valve itself, and depending upon the intake valve open and close, they will able to control the airflow quantity. So because of that, they are claiming that they are able to reduce the 10% reduction in the fuel consumption. And this technology, as I have already discussed, integrated starter alternator system. It is nothing but by integrating the starter system and the alternator system in a single unit, because to reduce the cost nowadays, almost electronics has been using for saving the cost and reducing the size of the system and improving the overall performance with the help of electronics system only will be this kind of development is going. So one of the technologies in that the ISAD, integrating starter alternator system. And next comes to the network protocols. Network protocols is nothing but, as in some 5-10 slides back I have explained to you, the engine ECU can be integrated with the other ECU in the vehicle. So that can be possible with the help of this different kind of network protocols like CAN, LIN, FluxRay, MOST. These are the different network protocols. One of the important network protocol is the controller area network. This is nothing but based on this network, the ECU can be communicating. Different ECUs, engine ECU can be communicated with the cluster ECU. Engine ECU can be communicated with the ABS ECU, like this. Why this has been introduced? For example, if you imagine without the communication, some of the informations gathered in the engine ECU will be needed by the clusters. Again, some of the informations gathered in the cluster ECU will be needed by the engine ECU. So if you, for example, if you want to share those information, then each and every wire has to be connected. So instead of that, if you will put in the architecture, or you can say the protocol or in the network, so everything can be shared. So here the architecture complexity, this slide explains. Typical Volkswagen fleet and vehicle consists of 11,136 electrical devices with 61 ECUs, and they are connected by the 3 CAN networks and sub networks. About 2,500 signals has been exchanged between ECU in a 250 CAN messages, and it consists of 30 to 100 sensors, and similarly 100 to 300 in a typical advanced vehicles. A typical modern car consists of a wiring harness more than 5 kilometers. So if you will take the wires inside the vehicle, it will consist of a 5 kilometers length. Like that wire, this is a typical cable harnesses. So that we can classify as a cable into different types, like engine harness, tailgate harness, like the different harnesses we can able to classify. Like in a harness, it consists of cables, connectors, ECU connectors, all those things. And if you will increase the more number of wires, and ultimately it will lead to increase the weight of the vehicle, and it will affect in the fuel economy. So instead of reducing the harness complexity and architecture complexity, they were nowadays using the protocols. Like this is the conventional wiring harness. Like each and every ECU has to be connected with the help of wires. But you see here is a CAN bus with the help of only 2 wires. All the information. This is the cluster ECU, and this is the transmission ECU, and this is the engine ECU, and this is the some other ECU. I think door control, and this is the again remote key. And these are again communicating with each other through the help of CAN network. And another important thing in an ECU, or you can say the engine electronics, is the diagnostic. So as we are saying that there are more electronics components has been introduced nowadays. This because of these electronic components, the complexity in the system has been increased. Like if, for example, previously if you'll take in case of older vehicles, non-electronically controlled engines, any faults in the engine can be identified by a normal technician, non-trained technician, or experienced technician, with by hearing the sound, vibration, noise, or driving, all those things. But nowadays, if any problem in an engine or any problem in the ECU related stuffs, it has to be diagnosed with the help of proper diagnostic tool. So for that, each and every ECU has a separate diagnostic module. So if any problem is there, according to the problem, it will put a particular diagnostic trouble code. For example, PC01. There are different diagnostic trouble codes where there are P codes, C codes, and B codes. P codes related towards the powertrain related errors, C codes related towards the chassis related errors, and another thing, C related towards the chassis related, and B related towards the body related errors. Like all these sensors, actuators, everything will be connected towards the ECU, and diagnostic system manager will be present inside the ECU, and this will be communicated through the help of a connector with the help of a generic scan tool in the plant or in the service station. And if any problem is there, through this scan tool you can able to note, like a P code. See here they have mentioned a P code P001 that will be identified or related towards some error, like crankshaft sensor signal failed, like that. Each and every error will be identified, and that fault will be displayed in the cluster with the help of a malfunction indicator lamp, like MIL. In the cluster in front of the dashboard you might be able to see. With the help of PC or a universal scan tool, you can easily able to identify the problem in any ECU, especially in case of the engine ECU. What are all the advantages of using an engine controls? Outstanding performance, that is improved engine response, precise engine speed control, optimized engine acceleration, slow engine speed control, increased reserve power, and in terms of fuel efficiency, better controls to delivery of the fuel, and similarly efficient turbocharge. So many control related functions you can able to adapt. Real-time control functions you can easily able to build in case of the by using the electronic controls, and as well as the easy diagnostic troubleshooting, great reliability, and especially integrating with the other systems. Depending upon this electronic engine control, you can easily able to integrate with the other systems. And comes to the conclusion and future perspective, or you can say the future direction of this engine management system research. Is currently the engine ECU has been developed only by the certain suppliers like Bosch, Delphi, as I have already mentioned. So there is a certain intellectual property rights will be there for them. They can't reveal their development strategy, control strategy, all those things. So as a OEM or as a university level or other persons who want to do the research, they can't able to access their thing. So in order to sort this thing, an open architecture based ECU, or you can say an open architecture based engine management system is need for the development in the present scenario. And next comes to the nowadays the engine control is depending upon the torque. So whatever the requirement given by the driver or other systems, everything will be calculated or controlled towards the torque, and finally that for the torque only all the control functions will be controlled. So if you will develop a low cost torque sensor to measure the engine torque output, we can able to make a closed loop control by using the low cost torque sensor. And one more thing, because of the fuel scarcity and all those things, hybrid vehicles has been using nowadays. So in order to provide the better degree of hybridization, better control functions has to be still developed. In order to save the time and calibration process, a simple way of calibration approach is needed, because in the engine ECU development, calibration is one of the biggest time consuming and a cost consuming process. So a simple calibration process is needed. And the engine control system of SI engine consists of various sensors in order to provide the efficient control output and to the actuators. So this sense, there is a wide scope to develop a soft sensor. Soft sensor is nothing but a sensor which does not have any hardware. With the help of a present sensing information, soft sensors will be used, and this is a need in case of a future system. And the next generation of diagnostic system should be in the cloud computing, or you can say the intelligent approach. If any problem is going to happen in a particular vehicle running on a road, the prior to the owner, the manufacturer has to know that through the cloud computing technology also it is possible. And enabling smart conditions like monitoring the driving condition, road condition, atmospheric condition, aging, all those things, depending upon the real-time scenario, the control system has to vary its control architecture functions. So these are also certain need in nowadays. Thank you for your attention. This is my contact information. If you want any clarifications, please contact through my email address. Thank you.